Morning, Josh. I don't hear you. I think your mic is off again.
Good morning, Mark. Can you hear me now?
Done.
To the
Now I can't. Oh,
smallest
yep, there we go again.
performance meeting.
Sorry, what was that?
Welcome to the smallest performance meeting in a little while.
Yeah,
Let's might have to wait a couple minutes, I guess.
yeah. People kind of trickle in. Hopefully, we'll get a couple more. But it's been small lately. I think we've kind of had a drop off in community folks showing up, and I'm not totally sure if that's just kind of summer people are gone a lot, or if it's that maybe folks are happy with the performance now and don't bother showing up. I don't know.
A lot of it summer.
Could be.
Experiencing sudden and intense deja vu.
Greg, what was that? Deja vu?
From the contents of this meeting room.
Yes. Well, Igor's here, and we might get Radek. Sometimes he comes.
So that shifts it by about 4 minutes the other direction, but
I have to find where I put that together. This perf Etherpad. Where did I put it? Reopen it back up, I guess. All right, so let's get this started. I'm gonna be on vacation for the next couple of weeks, so I imagine unless Sage decides to run this, we probably won't have it until sometime maybe second week of August. So having said that, let's see, PRs. This one, Greg, if you want to have a throwback to looking at the MDS, there is a PR here to optimize the way how max export size is enforced from ukernel. I don't know anything about MDS optimization stuff, so I'm not sure if that's interesting or not, but it's there. The Radek has op tracker work, and also Radek has his this cleanup to avoid extra rough counting in primary log PG PRs. So I think Radek's our winner this week in terms of new work. And then Niha's PR to limit the PG log length merged. That is fantastic. I should try to get that into my merged into or cherry picked into my branch here so that I can test with that, because it might affect the defaults I'm using for the memory limit stuff. If we don't end up peaking higher, I might have to change those a little bit, but yay, glad to see that got merged.
Yeah, it'd be really interesting to see how that affects your tests during recovery, especially.
Yeah, and I haven't even tested recovery yet. I've still been just screwing around with like normal work. But that was on my list of things to do, is look at recovery scenarios. So definitely getting that merged before I do that, I think probably makes sense. Or getting that cherry picked rather. Or just rebase my stuff on master, which probably makes sense to do again soon. Let's see what else. There's this EC Stripe Cache PR. I don't think anyone's looked at that yet. If anyone wants to review. What else? Sage Ed, the perf counter one for recording the latency of KV finalized. I mean, that hopefully isn't that big of a PR, I don't think, but that could be kind of interesting to see. I haven't seen KV finalize that particular thread being super like busy lately, but maybe in certain circumstances it might be. So it'd be interesting to see. My PRs are all stuck on this lib standard C++ runtime issue on Ubuntu 16.04. Ifu's going to try to fix it, which if he was here, I'd thank him again profusely, because that I don't understand why it's exactly happening or how to fix it. But hopefully he'll have make some progress on that. Maojian Peng has a couple of different PRs. I think Sage has been looking at them. Yeah. And then there's this kind of remove async recovery one, and that's gotten a lot of discussion. I think Sage is also in the middle of kind of discussing that. For anyone who has been intimately involved in that, it seems to be kind of subtle to me, the issue there. I haven't looked real closely at it, but for people that are interested, that might be worth looking at. I think there's been some progress on understanding what exactly the issue that's come up there is. So
the issue there is that it's very difficult, and there needs to be a proposed algorithm to do something that makes the data still be safe and consistent. And there's no such algorithm proposed yet.
So Josh, it's a real problem. We understand it now.
Well, it's not a real problem. It's a proposal to do something that's unsafe, and Sage is trying to get it to be done in a safe way.
Okay.
Possible.
So yeah, I didn't even understand that. So the proposal is an optimization that makes it unsafe.
Basically, yeah.
Okay. All right. Now I understand. Well, okay. Good luck. What else? Adam's on vacation right now, but before he went on vacation, he was looking at implementing some kind of thing for trying to model fragmentation of the different BlueStore allocators. I don't think I've seen any results from that yet, but it looks like there's at least some outstanding PRs here for it. Hopefully that will, once he gets back, he'll have a chance to get that merged. That'd be very interesting to know. Jason has been doing some testing with RBD workloads in one of our HATS labs and saw some just interesting behavior with stupid allocator and bitmap allocator, where bitmap allocator is actually doing a better job of utilizing free contiguous areas for random writes when available versus stupid allocator, which is only doing it until it kind of hits the end of the device and then starts kind of doing just random IO, which is, I guess, what you'd expect for 4K or for 64K random IO. That's what his test is. But bitmap allocators maybe actually being a little bit smarter about, using large contiguous chunks of free space to turn that random IO into kind of more sequential looking IO. Whether or not that's actually a good idea maybe is a point of contention, though. Maybe you don't want to use your large free contiguous chunks of space for random IO, even if it makes it kind of sequential. Maybe you want to save that for big objects or big writes if they should come in, and do your like 64K random IO to 64K open spaces or close to 64K open contiguous regions on the disk. So anyway, definitely he knows some differences in behavior. So anything that we can do to get a better understanding of what the fragmentation looks like and what kind of free space we have under different kinds of workloads of different sizes would be useful. Let's see what else. I'm sort of surprised that this RGW thread pool size to 512 has not merged yet. I can't imagine that is a particularly complicated change to do, but I don't think that has actually merged. Let me just double check to make sure I didn't miss it. Nope, not yet. So anyway, what else? Aging tests again for allocator stuff. Has anyone seen what's going on with this librd shared persistent read-only cache? I know it's been out there for quite a while. Is anyone kind of
not up in the latest stuff there? I think Jason would know.
Sure. All right. Well, that's been there for quite a while. It looks like it must be getting semi-regular updates, but has been kind of sitting around. Radix huge pages to limit page faults thing, that's kind of been kind of slow lately, I think. Yeah, I think a lot of this other stuff is pretty old. Yeah, not a whole lot. So, all right, move on to discussion topics. I've been continuing to work on cache balancing stuff, refactoring and cleaning up and trying to figure out reasonable defaults. In the current state that it's in, it needs some cleanup, but it's doing pretty well. I did kind of increase the number of priorities to currently user-defined priorities are 10 that you can set for KV meta and data. That potentially could result in if you actually defined every single one as an independent type, 30 different config values, but I think Josh and others convinced me just to shove this into a space delimited string, so now it's 3. You can kind of see what the defaults right now that I'm testing are there. That basically means that that at priority level 1, KV will look at 5 seconds of LRU cache, and then at 2, another 5 seconds for KV, 6 at priority 3, 6. I'm sorry, not 2 seconds. 5 seconds, 10 seconds, and then 30 seconds for priority 3 for KV, and then meta starts at 5 seconds. It's basically 5-second intervals and then the number of intervals. So if you're looking at the Etherpad, you can kind of see the layout there. That's just kind of a very rough idea on my part of kind of what sort of might make sense here. It seems to be working pretty well. This setup means that for small cache sizes, KV ends up using the majority of the cache, and then at large cache sizes, that all transitions over to metacache instead of KV cache, because you have meta hits happening really rapidly, and data that's in the KV cache ends up kind of degrading or getting old, and then kind of falling off and not being prioritized relative to metacache. So it kind of does the behavior we want, where for small cache values, everything's in metacache. For large cache values, everything's in KV cache, and for large cache values, all the ONOs end up in metacache instead. And then data cache kind of sits somewhere below all of that. So anyway, still testing going on with that, but I think it's kind of doing what it's supposed to do, which is good. And the performance numbers I'm seeing right now, I think, are probably going to be higher than just using static ratios, even when the static ratios are for a cache value that's like aggregate cache value that's larger than what the auto tuner has available to it. All right, so that's going well. One question that I proposed in, I guess, earlier that I think everyone here already knows about or responded to was looking at malloc plus placement new for allocating memory for a struct kind of all at once up front, rather than using, allocating memory for the struct and then allocating memory for, say, like a car star array inside of it. This all came out of RocksDB doing things that were kind of evil. So we might be able to still get some of the benefit of what they were doing without quite having it be as evil as what they were doing. Anyway, I'm hoping to look at that a little bit more too and see if there are any applicable places we can do some of that, maybe inside BlueStore for limiting or reducing the number of new and well, I guess malloc and free or delete calls that we make. So anyway, that's it. That's all I've got. Anyone want to talk about anything they're doing or working on? All right, Neha, I'm gonna pick on you a little bit. I was wondering. I remember when we had our meeting a couple of weeks ago, we saw that we might be able to reduce the amount of memory that was being used for pglog entries. If I recall correctly, we were maybe copying stuff into a vector or an array or something that wasn't strictly necessary. Do you recall that at all?
I don't recall exactly the same thing. I do remember that you brought this question that is there a way that we can reduce each pglog entry size, or do we actually know what the upper bound for that is? So yeah, I definitely remember that discussion.
So your PR right now at least bounds everything. So we at least know that we're not going to extend it beyond whatever is defined in the ceph.conf file, right?
Right. So we have this parameter called the OSD max pglog entries, which was there earlier but didn't really act like a max, because during recovery backfill we were just extending the log to whatever was easier for log-based recovery. But what my PR does is whatever value that you are going to give this parameter, it's just going to stick to it no matter what, whether there is recovery backfill or like a regular scenario. It's just going to have, that's the maximum upper bound for the pglog now.
Okay, cool. So that's really good. That will absolutely be helpful. And then, so okay, Josh, do you remember when we were walking through the code? I thought there was something where we were kind of like either copying these into some kind of like temporary data structure, or there's something I thought where we were using extra memory we didn't necessarily need to.
I think there might have been one case of, that I remember at least with maybe the rollback information that we didn't need for a replicated case or like that. I think there might have also been a few other things in the pglog data structures itself where we might have been like copying. I think one point you had pointed out was like the object names, kind of copying those around for a bit.
Yeah. I mean, there's that. Oh, maybe that's it. Maybe it was the names that we were copying into some kind of other data structure. I don't remember anymore. Did we take notes on any of that? Do you know?
Not sure.
Okay.
But that reminds me that we did talk about the rollback information being irrelevant in one case, and we also, I think, the size of the object, the name of the object also came up because we were particularly discussing, I think, RGW or something. So these two things definitely came up.
Yeah. Yeah, I think you guys are right. I think it was maybe the name of that string that was maybe getting copied. Maybe that was what it was. And we could reduce the amount of memory by not doing that. It's hard to remember. Well, anyway,
Yeah. Other thing about that is I think it would be good to take an empirical look at exactly how big these entries are and where that space is being used. Because sometimes looking at the code is a little bit misleading.
so in the mempool, just in some very, very, just random tests I've been running recently. Well, I guess they're not random. It's 4K random writes and RBD with a 256 gig volume, and I think it's 256 PGs on one OSD. I can verify that, but I think for PG log entries in the mempool, we're using around 400 megabytes of memory. So, there's a value, right? It's a number.
Yeah, 400 megs for how many PGs and how many entries per PG?
Yeah. It'd be, let's see, the default, whatever the defaults are, and one second. Yeah, 256 PGs. So I think, is our default like 3,000
Yeah, it ends up being 3,100.
entries?
So that works out to roughly 528 bytes, 530 bytes.
Sure. And that's RBD rather than RGW, which I guess you'd maybe expect longer object names.
Yeah. Especially with the EC having more rollback metadata too.
Yeah, that's true.
And the object names are much, much larger.
Do you have the numbers for an RGW test too, Mark?
Not off the top of my head. I might have them laying around somewhere, but it's easy enough. I've been running these tests like almost constantly while I tweak the memory tuning stuff, so I can very easily grab some in whatever next the next RGW test I run is.
Sure, that'd be great.
Yeah. Yeah, maybe I'll just record it during the duration of the test so that we can kind of watch it as it starts filling up the volume. See how quickly the PG log entry, mem pool increases. I imagine it'd probably be pretty fast.
Yeah, naturally get to
peaks at.
full capacity pretty soon.
Yeah. The other thing I have noticed in those tests is that I don't know if it's fragmentation or if it's more that we have just like spans that can't be released by tcmalloc. It's a combination, I think, of a lot of different things. But when the kind of auto-tuning code is rapidly shrinking or growing the RocksDB cache versus the ONode cache in BlueStore, we can kind of end up in a state where the amount of memory available to the cache to keep our heap size within a certain bounds decreases pretty dramatically. I think it's actually true maybe also for the PG log entries that are stored in memory. The more kind of different size of things that we have in memory, and the more we kind of remove those and add new ones in, the worse it seems to get. This is just kind of speculation and observation on my part, but it seems like when we have lots of different sized memory allocations, we can kind of confuse TC-malloc pretty easily. That sort of makes sense.
Yeah, it seems like a plausible theory. Not familiar with enough of the internals. But
I saw some. Just go ahead.
I was done. Go ahead.
I saw similar behavior with libc and gmalloc, and it seemed that tcmalloc is a bit better in this respect. But so at least for the sequences that were reproducible for gmalloc, tcmalloc behaved much better. But probably still has the same issue.
It might be that I've been trying to read up a lot about not only this kind of thing with like using placement new and trying to create like contiguous ranges for structs plus their pointer content, but beyond that, like mempools and kind of the trade-offs that are involved in allocation speed and if you're doing lots of deletes or not and this kind of thing. I suspect, given kind of how much we are creating and deleting stuff, that a mempool might be better for some things at least. If we have kind of the equal sized objects that we're allocating. But yeah, kind of, I'm not sure how much it helps if we're doing like more dynamically sized things like PG log entries, for example. You know, what does that look like? You know, if you've got a variable length string and you've got a static size structure, what's kind of the optimal way to allocate space for all that stuff, and where do you put it? I'm not quite sure, but it seems like we might be able to help TC-malloc a lot, or any of our memory allocators potentially a lot, if we can kind of make it well defined for them what things they're going to get, or not have a lot of different size things that are being created and deleted constantly, or at least limiting it, I guess.
Yeah, and yeah, that's another case where I'm curious about the actual size of these entries. If they like they certainly vary between RGW and RBD, but within one of those workloads, I imagine they're fairly consistent. So maybe
For
that we could just, have a slab allocator with a large size.
Yeah. For RBD, I would imagine they're consistent, but do you think they would be for RGW?
Well, I think that, with the object name being the main piece of variance there, if we had a style allocator that was able to accept like the largest object name we'd expect, or maybe the 80th percentile, 90th percentile, that kind of thing, that might be sufficient to avoid confusing TC-malloc so much.
Maybe. I guess I was thinking that in the RBD case, I would expect very, very consistent like object name lengths. But
sure.
for RGW, I'd be afraid that like if you really had an RGW deployment with like thousands of random users all using it at once, that it would be, you might have just, really variable length names for the objects.
Yeah, so you might waste like 4K of space for entry or something, but that's not a huge amount.
Yeah, maybe it'd be worth just eating it, and then not having to worry about the dynamic allocation. On Linux, how much stack do you get? Is it like 8 megs?
That sounds right, yeah.
Okay.
Not 64 or 42 kilos?
I don't think so. I think you get a lot.
But I don't mean them. I mean just pthread.
I don't know.
Let's Google.
Yeah, sorry, Radic. I'm not sure. All right. Well, in any event, lots of questions here. I think though, just based on the stuff that I've been playing around with recently, it seems like focusing in this area would be probably good for us. I think if we can do things to help the memory allocator, certainly when we switched over from simple messenger to async messenger, that helped dramatically. But it still seems like, based on some of these behaviors I'm seeing, where we try to keep the memory size limited, it's really interesting to watch TC-malloc struggling to do so, and kind of the amount of space that ends up available when we do that. I suspect that we'll see both. We could improve kind of the memory fragmentation effects, and then also probably improve performance quite a bit if we kind of approach this with kind of a goal of making things friendly. So anyway, maybe when I get back, I'll try to look at it a little bit more. But that I suspect that there's gains that we could make there.
Yeah, I agree. Certainly not doing anything optimal in terms of our memory allocation patterns in the IO path in general.
Yeah. All right. Well, that's all I've got. And unless anyone has anything last minute now.
Well, I kind of do if you've got a minute.
Yeah, we got some time here.
All right.
Ben?
So we're running into some problems with the PG overdose memory protection. Has anybody in the Ceph community had a similar experience? We're trying to install OpenStack, which creates a bunch of different storage pools, and most of them aren't that big, but like what we're seeing is that it's pretty easy to hit that limit. The the Mon max PG per OSD limit, and that's causing a lot of heartburn. And it's like I'm wondering if we kind of went to the opposite extreme there. Like before, there was there was not much of a limit on how many PGs you made, and that got us into certain kinds of problems because you can't really, it's hard. You can overdo that. But,
yeah, I definitely agree. I think we have seen other folks run into this as well, and so relatively recently, I guess we upped the default hard limit to be like 600 PGs per OSD instead of 400.
Yeah, that's the hard limit. I agree with that, but this is the soft limit. I mean, I think the soft limit seems to assume that you're only creating one or two big pools, and I'm not sure that that's true for everyone. And if we could loosen that up a little bit, you might just prevent a lot of people from getting frustrated with their deploys.
Yeah, I mean, the soft limit isn't really related to number of pools at all. It's just kind of related to the recommended number of PGs people have set up. So
I
the
thought it
PG
was.
calc type of tools should be giving folks good guidance there. That should stay within that limit.
Josh, that seems like a kind of convenient answer for us, right? Because as you increase the number of pools, you're going to increase the number of.
Sure.
So I posted the code that does the check, or at least that we think does the check, and it looks like it's adding up the different contributions for the pools, and then figuring out if it can handle the new pool with the specified PG. that right?
Yeah, exactly. I mean, it has to add up the number of PGs in total.
Right. So I understand why you put the check in place, but it might be a little too tight.
What is the consequence of this check is just a health warning, right?
No, it's basically the pool creation fails, and so the OpenStack deploy fails, and or there's enough there's enough difficulty getting an OpenStack deploy to work without without that whole issue.
Josh,
So
related to this
go ahead.
Okay, so
question for you. What if instead of keeping all PGs in memory, we did an LRU instead?
kind of entirely unrelated to this though.
But we could potentially allow people to increase the number of PGs then with, I mean, the
It's
whole limit
completely
right now is
infeasible,
right
Mark.
because, what?
It's completely infeasible, Mark. It will absolutely destroy any pretense at reasonable latencies. We can talk about why later, but no.
Let's just focus on the one issue at a time here.
Okay.
So with I guess I'm wondering how the OpenStack deployment is hitting this. Or maybe they're creating a bunch of these pools before very many of the OSDs are deployed, and that's why they're hitting this limit so soon.
Well, you're absolutely spot on. That was the first problem that was hit, was that they tried to create the pools before they created the OSDs, and that clearly didn't work. So they put in a check in their Ceph Ansible to say wait until all the OSDs are created before you create the storage pools, and that helps, but then their check may not be. But I mean, when I do the arithmetic, when they have reasonable PG counts set for their pools, it comes right up to the limit, that the
So
max.
Ben, it sounds like you're just like the deployments are happening on small clusters and they're setting small PG counts for pool, but that the total number of PGs is unreasonable. I mean, it's all configurable for a reason, but if you
Greg, our requirements that we impose on users is unreasonable. Our PG counts per OSD are unreasonable for users if we want them to be able to create a number of pools like is being set here.
Yeah, exactly. Okay, so this is still defaulting to 200. That's definitely not good. We should probably increase that to 600 as well, just to.
But Josh, that means our memory usage is going to explode on the OSDs.
It only does for this kind of initial deployment setup for presumably the full cluster is deployed, right? When you're deploying and you're adding OSDs and adding pools, and the thing isn't entirely up yet.
Won't every single PG maintain a log of every entry for that PG in memory once it's been written to?
Yeah, but you're not even doing I/O to these yet until as you're deploying this cluster. There's not going to be huge memory growth.
But if you assume that every single pool is at some point going to have stuff written to it, aren't you going to end up with a log for every single PG in memory eventually?
Okay.
Yeah, sure.
So second of all, Ben, is this where is this coming from? Is this a performance group doing stuff, or?
No, it's just people are trying. Well, it is the performance group doing things because we're one of the few groups that doesn't use toy clusters. To.
Yeah, no. Just the reason I ask is because we've heard about the hard limits being a problem, but not the cluster-wide ones.
Because I mean,
so here's that to us.
Right. So I mean, here's the thing. You basically have this PG calculator that recommends certain settings, right? And if what I want to do is make sure that the PG calculator isn't recommending things, and then the overdose protection limit is saying no, you can't do that, because that just creates a very confusing situation. Like he was trying to create a pool with like 1,024 PGs with 20 OSD. I don't think that's really outrageous.
like the actual numbers of things that you're doing? And like, is it just that the clusters aren't set up yet? Is that the only time you're seeing this, or when they
Well,
are set up, are you still getting weird results? Because the exact numbers like matter.
I understand that, but you know, if you want, I mean, so the specific case was 1,024 PGs for this VM storage pool, and they had like a few other pools that were smaller. And when you do the arithmetic, you only have 4,000 PGs because you have 200 PGs per OSD times 20 OSD. That's 4,000. And then the calculation, it takes the 1,024 and multiplies it by 3. And so basically it starts to come, when you add all these pools up, it starts to come right up to that limit. And, it might fit if you have all your OSDs up, but it's really close. And I think you don't want to be cutting it that close.
Ben, I completely agree with you. It is super easy to hit these limits. I hit them all the time.
I think the problem here is that we didn't realize that this was also on another hard limit that was set so low. So I agree we should just increase this hard limit because it is
Try
a
just
hard limit.
Right. I don't want to increase it up to 600 or something. I was just saying like maybe let's try 300 and see if that works out better.
I do want to draw attention to the fact though that this is going to increase memory usage on the OSD as soon as you write to any of these pools, right? Unless I'm quite mistaken.
It will.
Yeah, that's true.
And it's not insignificant. It's enough that we might be like, if we want to keep the OSDs to a certain kind of memory ratio or memory limit, we might be blowing all of our available memory on like PG log and not on other caches if we increase this dramatically.
Well, I thought that was a sort of a different related issue, which is there's the PG log max and min or whatever they were called, that the difference between them was causing it to consume a lot of memory. And there might be other factors as well, like what Niha's working on. But this is like a much more kind of urgent thing because like you can't even get the cluster running. You can't even get into memory trouble because you can't get there.
We could certainly make the logs shorter, right? If we made the logs shorter and increase the number of PGs, then you could keep the kind of the expected maximum usage roughly the same, but then you have shorter logs.
Right, and we had that discussion too.
That's why I'm asking for the specific. I mean, you gave us a good example then, but I want the specific things because, like, the PG calculator is maintained by I think someone in consulting, and like we definitely messed up with the hard limits in terms of what people tend to see happen during recovery scenarios, but those numbers were pretty accurate for where we want our memory to be allocated in the OSD. Like, if the calculator is giving you numbers that don't fit in that, then either the calculator is broken or it's being used wrong, or there needs to be a reckoning somewhere. And we're not going to do that reckoning in this meeting right now without all the data.
Okay. So you need more information, fine. But I was just kind of letting you know what I was hearing.
I think it is definitely reasonable to increase that hard limit because it is crazy to have a hard limit so low.
We do need to bump the hard limits. They've caused a lot of trouble, but like that doesn't mean that people should actually be running into them just because they're turning on a cluster. If they're running into it when they turn on a cluster, that probably means that it's configured badly, or else we lacked a lot of data.
I don't think these clusters were configured badly. I mean, sorry, but I think
and
we'll look into it.
I'm saying there's a conflict somewhere that it's not just the fact that the hard limit is set low enough to be troubling.
Okay, I mean,
so the two primary reasons I can think of and add to them or correct them if I'm wrong that we recommend so many PGs per OSD is one, the kind of random distribution nature of it, and then two, the locking behavior inside the OSD for the number of PGs that you have. If we the first thing, I think hopefully Sage's PG balancing code helps dramatically with. the locking behavior, no. But I wonder if we really need as many PGs per OSD now as we used to. Maybe we can get away with fewer, recommending fewer. Does that seem reasonable or something worth looking at more?
Yeah, potentially. I mean, I think the main thing there is the data distribution. And it's tough with like in the smaller pools at least. I guess they don't matter as much as the IO intensive ones, but
I remember both Loic and Sage's stuff when they were writing it. It looked like it really, really worked well to balance distribution, even at small PG counts. Like, you know, maybe 20 or 30 per pool seemed like it was doing
yeah.
a really good job with it.
Well, it's certainly balancing things in terms of data usage right now. What it's not taking into account at all is the IO.
Okay, and that's great. I mean, I totally agree with that strategy, but is that something that will ever be in Luminous?
Yeah, I mean, Mark's talking about more far future things right now, I guess. I think
Well, no, I mean the balancers isn't one of them in Luminous?
balances are in Luminous, yeah.
But, oh, they are.
Yeah, what I couldn't remember if it was Luminous or Mimic that it finally merged for, but it's there. I don't know I don't know how to even enable it or use it, but it's there.
Yeah, it's a manager module. So you can just turn it on with I guess a CLI command. And I think there's still a few bugs that pop up from time to time, but it's there.
All right, sorry about that. I didn't realize it made it back to.
It's only in the manager module though. Sorry, Ben, I didn't interrupt.
That's how it's implemented. Yeah, it's implemented as a manager module, so it runs online.
I know how to run that, so I mean, I'll look into that. I just didn't realize it had made it, so my bad. But yeah, if we had that, then we wouldn't need so many PG. Agreed.
You'll still have locking issues potentially if you're on really fast devices. So just keep that in mind.
Can you explain that a little bit? Locking?
So there's a PG lock. So if you have fewer PGs, if you do like a wall clock profile on the OSD, you might actually see contention for that lock, especially if you have really, really fast like NVMe devices. So just you'll have to be careful to watch for that and see if, you know, depending on how small you shrink the number of PGs in a pool to, you know, and depending on the number of OSDs, you could hit that, but you know, it still might be worth it.
Fair enough. I got it. All right, so
this.
Go ahead.
The locking issue applies to a situation when you have more than one TP OSD TP thread per your OSD work queue shard. That's our defined. However, this is our default configuration. On SSDs, we have 8 shards and 2 worker threads per shard. So the lower number of PGs you have, the more likely you will have a problem with PG lock contention.
Assuming that your pool is heavily used. I mean, so some of these pools are not. So I don't think.
Yeah. It's just there's a PG lock. It's a logical unit of blocking work. So if you have a bunch of contended IO to PGs, then reducing the number of PGs can slow you down. That's what all they're saying.
And it's also, by reducing the number of PGs, you're sort of indirectly reducing the size of your PG log, right? Your aggregate number of things that can get logged.
Right.
So you're kind of, you know, effectively reducing the length of that by shrinking your number of PGs.
Mm-hmm.
And reducing your memory consumption.
Right.
Exactly. All these things tie into each other and kind of it's one of the things that's complicated for the user, right? Is that by tweaking certain things, you affect other things.
All right, I've definitely got some homework to do. Thank you. Thought of it. So, if I find the PG calculator isn't consistent with the PG limit, then I'll let you know.
Great, thanks, Ben.
Cool. All right, we got 10 minutes if anyone wants to discuss anything else. Otherwise, we can wrap it up. Any takers? All right. Well, I will let Sage know if he wants to run the meeting and have it in the next 2 weeks. He absolutely can. Otherwise, I guess have a good couple of weeks, folks, and I will see you probably second week of August.
All right, take care, Mark.
All right. See you later, guys.
Later, everybody.
Nice work, holidays. See you.
Thanks.
Bye.
Bye.
Bye.